Assalamualaikum and salam sejahtera everyone. In this session, I am going to show you on how to answer question 2 for individual assignment part 2 BT10403 statistics for business and economics. Question 2 is related to chapter 8, the interval estimation. So let us first read the question. Question 2.1. A family is relocating from St. Louis, Missouri to California. Due to an increasing inventory of houses in St. Louis, it is taking longer than before to sell a house. The wife is concerned and wants to know when it is optimal to put their house on the market. Her realtor friend informs them that the last 26 houses that sold in their neighborhood took an average time of 218 days to sell. The realtor also tells them that based on her prior experience, the population standard deviation is 72 days. A. What assumption regarding the population is necessary for making an interval estimate for the population mean? B. Construct the 90% confidence interval for the mean sale time for all homes in the neighborhood. So we have a number of key information based on this statement. Number one is that we know that the number of sample or the sample size is equal to 26 houses, and the average time to sell a house is equal to 118 days, as well as the population standard deviation, in this case equal to 72 days. Apart from that, in order to construct the interval estimate, we are given a confidence interval of 90%. So in order to answer question 2.1, you need to be able to understand what does it mean by interval estimate. So here from the slide, we will try to at first discuss or briefly discuss what does it mean by the interval estimate and what is the purpose of conducting or estimating the interval estimate. So the interval estimate or confidence interval provides a range of values that with a certain level of confidence contains the population parameter of interest. So here you can also see that the confidence interval can also be referred as the interval estimate. So this interval estimate will help us or provide us a range of values. So when we are talking about a range of value, basically we will have two values, minimum value and the maximum value. And we believe that the population actual information is located within these two intervals, because it is almost impossible to obtain the actual information about the population. For example, the population mean or population proportion, since it is impossible due to certain limitation, time limitation, for example, or financial limitation, we might not be able to estimate the true value of the population mean or population proportion. So based on the information that we gathered from a sample, we can determine, or we can identify, or we can create the interval estimate that will provide us a range of values, the minimum value and the maximum value, where we assume that the actual value of the population mean or proportion is located between that two values. So in order to construct a confidence interval, we have to use this formula. In the formula, to determine the confidence interval, we have two components. Number one is the point estimate. So basically, or normally, the point estimate can be the sample mean or sample proportion. We use sample mean as the point estimate when we wanted to create the confidence interval for population mean, while sample proportion is used when we wanted to construct the confidence interval for population proportion. Another component in the formula is the margin of error. So this margin of error accounts for the variability of the estimator and the desired confidence level of the interval. In this formula, you can also see the plus minus sign. So these two signs or mathematical operation will help us to construct or to determine the minimum value as well as the maximum value for the estimation. If we can go specifically into the formula, as I mentioned before this, the point estimate can be population mean the point estimate can be sample mean denoted by X bar or sample proportion. So when we wanted to construct the confidence interval for population mean, then the sample mean will become our point estimate. On the other way around, when we wanted to construct the confidence interval for the population proportion, we will use the sample proportion as the point estimate. The margin of error is comprised of two subcomponents, as I mentioned before this during our previous synchronized session. The margin of error can be divided into two subcomponents. The first subcomponent is the z value based on certain significant level, while the second component is the standard error of the estimation. First component is the z value based on certain significance level that is divided by 2. Second subcomponent is the standard error of the estimation. So this significance level denoted by the symbol alpha here is equal to 1 minus confidence interval. Later I will show you on how to determine or obtain the significance level based on certain confidence interval given in the question. While here we have a sigma that shows the population variance. And of course we have n that is to represent the sample size. So the standard error is constructed by dividing the population variance. Sorry, this is supposed to be population standard deviation instead of population variance. if I can correct the slides first. As I mentioned before this, the standard error is equal to population standard deviation divided by square root sample size. In order to understand further on the confidence interval, let us look into an example. Here, the example is that we are trying to construct the confidence interval for population mean when population deviation is known, or population standard deviation is known. There are two situations in constructing the confidence interval. One is when we know the population standard deviation. Another situation is when we don't know the population standard deviation. So, a sample of 25 cereal boxes of Granola Crunch, a generic brand of cereal, yields a mean weight of 1.02 pounds of cereal per box. Construct a 95% confidence interval of the mean weight of all cereal boxes and assume that the weight is normally distributed with a population standard deviation of 0.03 pounds. So in this case, we do know the population standard deviation. So the interval estimate of the sample mean will be point estimator, which is the population mean, the z-value for certain significance level that is divided by 2, and the standard deviation of the population that is divided by square root sample size. So this is what we know so far. We know that n, sample size, is equal to 25, x bar, or sample mean, is equal to 1.02 pounds, the population deviation, that is equal to 0.03, and the significance level, that is equal to 1 minus 95% confidence interval. So significance level is equal to 0.05. We know that the significance level is equal to 0.05 by subtracting 1 to the confidence interval of 95%. So 1 minus 95% is equal to 5%. 1 minus 0.95 equal to 0.05. So there are a few steps that we have to follow in order to obtain the confidence interval for the population mean. Step number 1 is to find the z-value at certain significance level that is divided by 2. The reason why we use z-value is that because we do know the population standard deviation. Remember, if we are not being provided the population standard deviation, then instead of a z-value, we have to find the t-value. So in this case, since the significance level is equal to 0.05 and significance level that is divided by 2, because we have two values, we have two tails, is equal to 0.025. Thus, z-value at 0.025, because 5% divided by 2 is equal to 0.025, is equal to 1.96. How do we know this? By looking into the t-distribution table. So this is an example of a t-distribution table. In order to obtain the z-value from the t-distribution table, we have to know two key information. One is the degrees of freedom, and second, the level of significance. So Since we know the information about population standard deviation, in that case, instead of t value, we will try to find the z value. And in a t distribution table, the degrees of freedom for z value is equal to infinity. And the second information, as I mentioned before this, is the significance level. So the level of significance can be obtained from this area. And here, based on the question, we know that the significance level that is divided by 2 is equal to 0.025. So from the t distribution table, we can obtain the z value that is equal to 1.96. Since the degrees of freedom is equal to infinity, here we also know that the level of significance divided by 2 is equal to 0.025. Keep in mind or be aware to look for significance level for the upper tail area or the one tail area only. So, step number 2, after we have obtained the z value, in this case 1.96, step number 2 is to find the standard error. Standard error is equal to the population deviation divided by square root sample size. We know that the population deviation is equal to 0.03 and the sample size is equal to 25. Thus, the standard error of the estimation is equal to 0.006. The third step is to determine the margin of error by multiplying the z value based on the certain significance level that is divided by 2 with the standard error, in this case equal to 0.006. So we obtain the margin of error that is equal to 0.012. So step number 4 is to form the interval estimate by adding or subtracting the point estimate or the sample mean based on our question with the margin of error. We know that the point estimate is equal to 1.02. The sample mean is equal to 1.02. And our margin of error is equal to 0.012. So the interval estimate will be 1.008 and 1.032. So here we can conclude that with 95% confidence, since we are using 95% confidence interval, so with 95% confidence, the mean weight of our cereal boxes fall between 1.008 and 1.032 pounds. We don't know the actual population mean for the cereal boxes, but we do know that based on 95% confidence that the population mean lies or is located between 1.008 and 1.032. So that is how we construct the confidence interval for population mean. And by knowing on how to construct the confidence interval for population mean, I believe you are good to go in answering question 2.1. Now we move to question 2.2 or sub-question 2 for question number 2 in the individual assignment. If we can read it, a random sample of 8 drugstores shows the following prices in dollar for a popular pain reliever: 3.50, 4.00, 2.00, 3.00, 2.50, 3.50, 2.50, and 3.00. A. What is the standard deviation for the sample? And B. Assume that the normal distribution for the underlying population to construct the 90% confidence interval for the population mean. Answering question A is pretty simple. All that you have to do is to use the formula for standard deviation for the sample. For B, on the other hand, we are required to determine the confidence interval when the population deviation is not being provided. So remember, when we don't know the population standard deviation, we have to use the sample standard deviation to construct the confidence interval for the population mean. So in order to help you, or in order to guide you to answer question 2, let us use this slides over here. So here, confidence interval for population mean when sigma is known. And here, the confidence interval for the population mean when sigma is unknown, just like the situation that we have in question 2. So in order to construct the confidence interval for population mean denoted by the symbol mu, when sigma or population mean is unknown, we have to use this formula for the confidence interval, where x bar is to represent the sample mean plus minus t value at certain significance level, that is divided by 2 at certain degrees of freedom, times sample deviation, that is divided by square root sample size. So instead of using a t value, in this case, we have to use the z value. And while using the population deviation, when we do know the population deviation, in this case, we have to use the sample deviation. Example, Jared Bean wants to estimate the mean miles per gallon of all ultra-green cars based on a 90% confidence interval from a sample of 25 cars. The mean and standard deviation of the sample are 96.52, so this will become our point estimate, and 10.70. So 10.70 is the sample standard deviation, respectively. Assume that miles per gallon follows a normal distribution. So it is important for us to assume that the sample follows a normal distribution before we can construct the confidence interval. Because if the distribution is not normal, then we will not be able to construct the confidence interval, be it for population mean or for population deviation or population proportion. So here we do know that the sample size is equal to 25 because we have 25 cars, and the point estimate, in this case, sample mean is equal to 96.52, and the sample standard deviation is equal to 10.70. And since the confidence interval is equal to 90%, we do know that the significance level in this case is equal to 10%. 1 minus 0.90 equal to 0.10. So of course, a number of steps need to be taken in order to construct or to determine the confidence interval for the population mean. Step number 1 is to find the t value at certain level of significance, that is divided by 2, because we have 2 tails in our estimation, and degrees of freedom, that is equal to 25 minus 1. Why is it that the degrees of freedom is equal to 25 minus 1? Is because we do know that the sample size is equal to 25. While when we do know the population mean, on the other hand, our degrees of freedom will become infinity. Because in that case, when we do know the population deviation, we have to use the z value. And the z value's degrees of freedom is equal to infinity. On the other hand, the degrees of freedom for t value, since we don't know the population deviation, the degrees of freedom of t value is equal to 25 minus 1, or n minus 1. So here, t value for significance level, that is divided by 2, with the degrees of freedom that is equal to 24 is equal to 1.7109. How to determine the t value is to refer to the t distribution again. Remember, before this, when we are looking for the z value, our degrees of freedom is equal to infinity. While when we are looking for the t value, the degrees of freedom will become n minus 1. So 25 cars minus 1, we obtain a degrees of freedom that is equal to 24. So 24 is our degrees of freedom. And we also know that the significance level that is divided by 2 is equal to 5%, because we have 0.10 divided by 2 is equal to 0.05. Remember that we have to refer the value for the degrees of freedom at the upper tail area or one tail area, because some of the t distribution table reports for the two tail area as well. So when the t table shows the two tail area instead of an upper tail area, then in that case we don't have to divide the level of significance by 2. On the other hand, when the t-table, just like the t-table distribution that we have in this session, since in this t-table or t-distribution table, we are being provided the upper tail areas, in that case, we have to divide them by 2. We have to divide the significance level by 2. So significance level 10% divided by 2, we have 0.05. So this will become the column that we have to refer to in order to determine the t value of our estimation. So here we do know that the degrees of freedom is equal to 25 and our significance level is equal to 5%. Thus, our t value is equal to 1.7109. 1.7109. So that is how we obtain this figure over here. After we have obtained the t value, next step is to find the standard error. So standard error in this case is equal to 10.70 over square root 25. Remember, in this case, our deviation is the sample deviation instead of the population deviation. So that is why instead of having a sigma, we have this symbol for lowercase s. Step number 3, determine the margin of error. To determine the margin of error, all that we have to do is to multiply the t value with the standard error of the estimation. Since the t value is equal to 1.7109 and the standard error is equal to 2.14, Thus, the margin of error is equal to 3.66. The last step, or step number 4, is to form the interval estimate by subtracting or adding the point estimate with the margin of error. So here we do have the point estimate, which is the sample mean that is equal to 96.52 plus minus our margin of error that is equal to 3.66. We have formed the interval estimate that is between 92.86 and 100.18. So we can conclude that with 90% confidence, the mean weight of all cereal boxes falls between 92.86 and 100.18. So that is basically what we suppose to follow, or what we suppose to do in order to answer sub question 2